So today we'll keep working on our buy some milk to-do list. This is a part 2. If you haven't yet, please check out the part 1. In the part 1 we have already got the tasks, and we have finished 2 of them, and in this part 2 we will finish the rest too. If you are new here, I'm Juntao. I help people write better code. And along the way you will see why TDD is helping us as a developer, and how they protect us from breaking the existing applications, and is more confident to make big changes and big refactors, and makes our code much more cleaner and maintainable. Yeah, let's get started. Awesome, we have this component defined, we have a test, and then we actually have already done these 2 on the list. So the next one will be add new item to the list. Let's close these 2 first, and then we will need to add new item to the list. Alright, so what we have in here is we need to arrange first. Again, we will start with the empty array. So we start with render a to-do items. We don't have any, which is fine, and then we will do some actions. We will need to on the screen we need to find a input. We'll give the input a name. Let's call it a input, and then we will fire event to that input. It will fire event. We will trigger change event on the input, and with the data like target value. Value to be something like buy some oranges. We should use get by test ID, yeah. And then we can either add in button, find a button and click, but based on the requirement we have, it's triggered by the enter key. So we will trigger the key down event to the input, and the key will be enter, the code will be enter as well, and the char code is I think 13. It's just to simulate a enter key, and then we're expecting that this screen dot get by text by some oranges to be in a document. This is exactly what we're expecting from the component. So if you run the test again, it will fail because the data test ID input cannot be found, which again, this is the infrastructure failure. It's not the error we're expecting or the red test we're expecting. It's just a not working test yet. So now let's modify our code a little bit and return this, and we will need to put an input and with the test ID as input as well. So now if we run the test again, it says buy some oranges cannot be found. That is the input on the page, but there is no oranges or anything like that on the page, which is a purple failure. That's what we're expecting, right? So we want, when we type in the buy some oranges, it should be shows up on the page after the keystroke. So now let's fix that. So in to do, so we will need to maintain some internal status to make that happen. So the first thing we'll need to do is we will maintain a to do. Alright, and so set to do use state. This will be a string. Default value is empty, and that's the when you change like any key change, it will set the to do, and eventually when the enter is pressed, we will add the whole to do into the to dos list. That means we need another to dos and or items. I don't know, set to dos. That is a it's not only it should be array, and we call it to do item array, and the default value will be the items passed in from the props, and this items iteration will be the to dos iteration, right? So the to dos will be initially it will be the items, but whenever some change made on the to dos, we can rerun it with this internal state. So here we will need a function that handling the key change. So on change will be like handle change. Let's say it's handle change, and we can create that function here. It's what we're going to do is set to do the e target the value, right? That's so whenever a key, the value change inside the input, we will set that as a to do. The e, of course, it's react change event from HTML input element. The react, what is okay, import react, yes please. And then now we will need to handle the on k down event. So let's say handle k down. So for can hit down, it is a react keyboard event from the input, of course. And then in this case, we will check if the key is enter. If it is, we will set to dos to. So first we spread the current to dos, and then we will add a new to do at the end of the list, which is we need ID in some kind, and we need the content to be the to do, right? So now we kind of have the structure pretty clear. So now we have the structure, despite the ID here. So we have the input, and whenever a change happens, it will set the to do, the temporary to do in a input box, and whenever a enter is happened, we will set the to dos, the list with the current to dos plus a new correct item. So the ID we want it to be unique, and yeah, we can install that a library called npm install what do you call that? It's a UUID. Save it, and we also need the types UUID, right? Okay, so now we have the UUID. Let's import that. Import v4 as UUID, from UUID, right? So UUID is a function now. You can call it whenever you like. For example, we would like to call UUID each time when user press the enter, and then we use that ID here as a new ID for the element. And if we go back to the test and then run it again, it should pass, right? And yeah, it passed. We can now add one more item into the list. That's pretty cool, right? We have implement 3 or 4 tasks already. Back to our story, we have a passing test. Actually, we have all the tests been passing at the moment. If we go back to this test file and run all of them, you will see all the tests are passing. Now, buy some milk application, run the item, run the multiple items, add new item to the list, are all passing. It's time for us to do some refactoring. So now, if we look at the the implementation, it's not that too long, but I still can feel that some of the logic is happening inside the to-do, which is not necessarily happen here. For example, we have a input that handling all the input stuff like user typing, event, and the state management as well. We also have a to-do like a read-only mapping. It's only rendering whatever passed in and present it on the page, right? It's like naturally you can think that 2 parts of our application. I think we can extract one component out and leave the to-do relatively simpler. So for instance, we can definitely move the handle change, handle key down, and the input into their own component. Let's see, we have a component called to-do input. What it does is nothing but run this input. We can just copy that over. Let's see, we have a return element like this, and we will move these 2 as well into the component. Actually this set statement as well. That's the problem here, the to-dos, right? We need to insert a to-do into the to-dos list, but we don't have to do it right away here. We can simply call back the caller, right? So like we create the item here without actually insert it into the to-dos. So for example, if we have a callback to this component, let's say it's on item added, which is on item added, which is a function that accepting a item, the type will be to-do item, and it returns nothing. And whenever a enter pressed, we will call this callback with a parameter like this, id equals to id, and the content equals to to-do, the internal state. So now this to-do input is pretty clear, right? It's handling only this to-do. It's not going to expose its internal state to outside. But when enter is pressed, it will call back to the caller. So the color will be input, to do input, to do input. On item added, we will call something here. So for the on item added, we will expecting a item, right? It's to do item, and then inside it we will do something like this one. We just set to do and add the item to the end of the list. So then we will use this function here, and once we have this linked, we can get rid of this input and these two callbacks and the to-do state management. And if we run the test again, yeah, all of them are passing now. So now if you look at the implementation, it's much easier. The to-do is simplified as it's using the to-do input, and for input itself, it's only handling all the events, the key change, the key press, but it's not going to expose the internal to-do to outside world. And we can do even further. We can extract this to do. We can extract this to its own file. Let's say it's a to-do list, to-do input, and we need to export this interface. And yes, let's import that from the to-do. So inside the to-do input, we have all the logic for the input, and in the to-do, we don't have anything about like the key, the enter, the key change, or the input itself. So now we have the to-do input split out, and if we run a test again, it's all passing. That's the most beautiful part of the TDD approach. Whenever you made a mistake, you will be notified immediately, and then you fix it and you run test again. You will be more confident when you're coding. For a smaller application like this, you have seen the benefit. For larger ones, larger projects which has like hundreds of files, hundreds of tests, it will be much safer to have this test to cover you, so you won't break the existing functions accidentally. It's applied. It holds true whenever you are adding new functions, or you are changing the old behaviors, or even like you are trying to make the code quality a little bit better, like refactoring, extracting some component out of the old ones. With this test to like backing up, you will be more confident to make these changes. Continue to our last task, which is mark item as done. That's so basically we will need to initialize the to-do list with one item first. So basically we will initialize to-do component with one item in it, and then we will click that item, and then we will expecting it's gone, like there's nothing on the page left. We can start from here. It marks an item as done, and we render a to-do with one item in it. Let's say ID 1, content to be, I don't know, buy some milk. And that's the first step. We will prepare the data first, and then we'll need to find that item. We just say screen.get by text buy some milk, and give it a name. Let's say we call it item, and then we click this item, and then we expect the screen.get. It's actually query, because we are expecting it to be disappear from the screen, so we will say not in the document. Now if we run a test, but it's still there, right? It's expecting the document to not contain element, found the element on the page. So yeah, that's yeah, we need to fix that. So in to do, we need to register a in a to-do list. We need to register a on-click event. We need to register on-click handler. So on-click, we will need to pass in the item to identify which item we want to hide or like we want to delete, right? So we will need to pass in let's say mark item as done by passing the item. So basically it says whenever a click happen, we will pass in the current item to that function. That function is because it's accepting a to-do item, right? And it will need to filter out the item with the same ID, and then use the new filtered result to set the to-do list. We need to to-dos filter pick up one to-do at a time, and then check to-do the ID not equals to item.id, right? This filter will give you the result of all the elements that should not be hide, and then we give it like I don't know, new to-dos, and then we set to-dos with these new to-dos as a result. So yeah, let's give it a try. Yeah, the test is now passing. So you can see when we click the atom, and what happens is it will try to fill out that particular ID and use the filtered items as the new to-dos. We probably can give it a better name here. We call it filtered. Alright, so our test now passing again. That's all I have for today. I hope you enjoy it and maybe learn something from it. That's awesome. If you haven't yet, please consider subscribe and like it. If you have any questions, or if you want to learn something else from me, please comment below. And until next time, see you.